Testing, testing. Can everyone in the back hear me just fine? All right, perfect. So good evening, everybody. My name is Kim Stuart, graduate student here at the University of Washington, and today I'm going to present my TAC talk, an analysis of real-time streaming of sensor fusion and smart buildings. I'm working under Dr. Matthew Tolentino in collaboration with Intelligent Platforms and Architecture Labs, IPA Labs. So my simple goal for this talk is to try to keep everyone awake for the next 6 minutes to make sure no one falls asleep. In order to do that, I do have to get rid of some early terminology from the beginning. So the basis of my research is going to involve sensors and servers. So simply put, a sensor is just some device that's capable of receiving and transmitting some type of data to some other end device. So it could be another sensor, or it could be a computational server. With that, a server is just something that's able to store that data and then perform computations on the data. So anyone who has a desktop is familiar with that. But what's interesting, a lot of people overlook that our brains are actually living servers. So we have the ability to store 2 and 2 in our mind, and we can compute that it's 4. So we ourselves are servers. So with that, I want to give a little story to sort of preface my research. This is just a story of me growing up with me being a server. So this is me in the first grade. So my brain is pretty small at this point. I'm still growing, so I'm able to do basic stuff like 2 plus 2, some basic addition and basic subtraction. However, as I grow up and my brain gets bigger and bigger and I get smarter and smarter, I can now hold more sensors and I can now perform more complex computations. So now I'm able to do stuff like multiplication, division, and as I get even older and my server upgrades even more, I'm able to do stuff like calculus and trig and all these complex stuff. So the takeaway of it is that the more and more sensors that we need in order to provide computations, we need to upgrade and we need stronger and stronger servers in order to do so. So with that, let's take a look at some of the use cases nowadays for sensors. Like, why do we use sensors? So anyone who's into fitness might use Fitbits. Fitbits is something that can track your heart pulse, monitor your sleep patterns and stuff like that. Anyone who's a foodie like myself, we even have smart refrigerators that can now look at what's inside your fridge while you're away. It can let you know what you're low on and what you need to restock on. We even have something called a collision avoidance system. So in cars now, it actually has motion sensors which can detect if you're getting close to an accident, and it could it could force stop your car for you without you actually having to slam on your brakes. We have something called smart grids. A subsection of that, which you'll see, is homes, and that's basically the premise of what my thesis on. I'm dealing with smart buildings and smart homes. So now that we know that more sensors require more servers and more computational powers, let's take a look at some of the challenges that we face with that, with adding more servers. For one, on the residential side, you'll notice that it's very costly just to go out and buy more servers. Like, it's very costly. And to that point, the setup and maintenance, if you're going to do it yourself, if you don't know what you're doing, is also something that takes a lot of time. On the business side, cost is another thing. But also, you're not able to just decide, I want to put a server here, I want to put a server there. Sometimes, according to building blueprints and safety compliances, the best place to place it might be in front of a fire exit or something, and you can't do that because of the compliance. So what it boils down to ultimately is cost is something that we want to reduce. Do we need to buy more servers, period, or can we just work with what we have? So I have an experiment that aims to solve that. And I'll just sort of walk you through what's going on. We have sensor data that's just being ingested into some type of a platform. The platform that I'm using, it's called Apache Kafka, and it has the ability to route the sensor data into different ways. And we'll define that as a topology, something that determines where the data is routed to. So in this example, we have a rooms topology, which is 6 rooms. So all the sensor data for a given room is being sent into its own dedicated topic. Inside of a room, there's 4 different sensors. So if we wanted to, we could break that down into sensor topics, which would give us 24. We could also combine these by floor, which would give us a topology with 2 topics for floors. And the most common way people do it is they just flood everything in one by one by one. So we have this building topic with a single queue that's just filing everything up one by one by one. From there, it gets sent to some data storage file system where we perform computations on it. So the question is, are we doing it the right way? Or is there a way that we can minimize costs and not have to buy additional servers? So after running a couple of experiments, a couple of runs, we noticed a couple of things. The most common way people like to throw data when we're streaming it is just into a single queue, which we show in this building topology. You're not getting that many jobs serviced per second. You're only getting about 50. But if you increase parallelism, and add more computational servers to perform more computations at once, if we look at the floors topic, where we're able to split it into 2 queues now, we're able to compute now roughly about a little over 350 transactions per second, so a lot better. If we increase the parallelism even more, and we switch this to rooms, now we're able to service about 500 jobs in a little over a second. And then if we do it with sensors per topic, then we can service 500 jobs or more in less than a second. So the main takeaway on this is that before you decide to just go dump your money into buying new servers and new equipment, you can find a way to basically maximize the efficiency of your current server to make sure that you're optimizing the way at which you're computing data and computations. So thank you very much, and have a good evening.